Hello everyone, today we'll be discussing Codeforces round 894, div 3 problems A to G. Uh, so I'll discuss the first problem. तो इसमें क्या दिया हुआ है uh, we, there is a n by m grid of letters and in that letter this girl Vika selects some of the columns. She selects exactly four columns among them and the thing is among those four columns there should be in the first column there should be at least one v, in the second one there should be at least one I, in the third one there should be at least one k, and in the fourth one there should be at least one a. Yeah, so basically she wants to select four unique columns. So we want to know if it is possible or not. Basically this was the explanation of the question. So if you look at the first test case, you can directly see, you can select the first four columns only, vi, k, and you can form the word Vika. Basically, she wants to form her name. Now, let's look at the second example. Here, if we see, it's BAD CARPET. There's clearly no way to select columns here. Like there are only three columns, and we want four columns, right? Here there are four columns, and if we see, in the first column there is one v, in the second one there is one I, in the third one there is one k, and in the fourth one there is one a. We can form Vika again. Now look at the fourth test case. Here in the first column there is one v, in the second one there is one I, in the third one there is no k. So we can't form the word Vika here. So answer is no. In the fifth test case, if we see, we can select the first column, second column, third column, fifth column, and seventh column. So, like, yeah, we have to do it like this. So, what would be the approach for this? Like, if we are given n by m grade of like characters, so what can we do here? So basically, it is the approach would be simple, greedy. We'll select the first possible. Check the first column, and we'll do it. We'll check if there is a V there, right? And after we have uh, we get a V. After that, we have to check for I. After that, we have to check for K. After that, we have to check for A. So basically, we can make a pointer type of thing. Initially the pointer is z, take the pointer as z, it is equal to 0. 0 means that none of the character has yet been hasn't occurred yet, so I can show you my code only, that would be good for the approach. So z equal to 0, no character has occurred yet. So now for each column, basically there are m columns, right? So I iterate through the columns. For each column, I go from up to down and see, like there are four cases, right? If z equal to 0, I have to look for v. If z equal to 1, I have to look for I. If z equal to 2, I have to look for k, and if z equal to 3, I have to look for a. So after that, I basically increment z by 1. So that for each z I know what I need to find, v, I, k, or a. And of course I break it because I have to end this column. I don't have to look further into this column because I can only select one character from the column, right? So that I can get four unique columns. So I have to break after each of the after I get any of the character, and I'll move to the next column. And if in the end z is equal to 4, this means that when this this case has occurred, z would be equal to 4, and after that it isn't going to increase, right? So z equal to 4 means I have been to every one of them, V, I, K, and basically I've got Vika. So if Z equals to 4, the answer is yes, else it is no. If anyone has any doubt, can ask, else I'll move to the next question. And now I'll be discussing the second question here. Yeah, here a list of number is given. List of numbers is given. So in this list, yeah, wait a minute. Sorry for the pause. Wait a minute. My bad, yeah. Hello, Priyank. We'll be discussing till the last problem, G. So this is the second problem. Here, a list of numbers is given. A sequence of positive numbers of length m is given. Then what she does is this is the rule to make another sequence B. First of all, she writes the very first number of the sequence. After that, she writes all those numbers so that a of I is greater than equal to a of I minus 1. So she constructs another sequence B. But the thing is, in our case, B is given. We have to construct any of the A which is possible to be like any of the possible A so that B can come. But we have to keep in mind that length of A is less than equal to 2 into length of this. So we have to construct an A from B. So if the rule is basically a number would be written only if the number previous to it is less than equal to this, right? So actually, it is quite simple to be honest. If we see that the current A of I number is greater than equal to the previous number, we don't need to add any number between them. Like they can go as it is, right? But if this is the case where A of I is less than A of I minus one, so we need to add another number, right? Uh, because uh, because 3 won't be able to come if the previous number wasn't less than equal to it. So we can add 3 in between them, because if we add 3, this 3 would be the part of our answer, and the 3 we added wouldn't be the part of the answer because 6 is greater than 3. So like as I was talking, if I have an array something like 1 7 6 2 5, something like this, what I'll do is, first of all, I'll write a of 0 in the number. Basically, this is the array B, my bad. So, a dot push B of 0. So, after that, for every number int I equal to 1, I less than n, what I'll do is, I'll check. Basically, I've written the code. You might see it here. Yeah. This is my code here. The vector, basically, I've taken input array as a only. So yeah, I have first added a of 0. Then I'll see if a of I is less than a of I minus 1. Then only I'll add this a of I. Uh, I'll add the a of I. Basically, this is the a of I which is between both these numbers, and this a of I is the original number which is originally in the array. So if this happens, then only I'll add it, and I have to add the original number in any case. So in the end, I print the size and the array, and it is the question is done by this method. If you look at the examples also, like if I make it 4633 with my approach, it would be 4633, and it suffices the conditions. For 123, it would remain as it is. For 17957, it would be 179 557. Yeah, so basically, it won't be increasing 2 into n ever, because we are at max adding n minus 1 numbers. If you see, like we are only adding one number in between the two numbers. So yeah, this is the approach for the second question. If any doubts, can ask. Now I'll move on to the third question. So yeah, so there is an array given which is which doesn't increase. Basically, it is decreasing. We can't say exactly decreasing. It is non-increasing. Like numbers can be equal, and it might be lower if the j is higher. So like this, the tower is made. Now they are asking if we add these towers horizontally. Basically, if the first tower is added horizontally, like this one comes here, this one comes here, this one comes here, this one comes here, and this one comes here, like this. So we want to know if they are identical. If we put it horizontally, it is identical. So what does it mean? Like basically, if we look at it, this was the first element of the array, this was the second, this was the third, this was the fourth, this was the fifth. Now, if we add them horizontally, what is the first element of the array? So if you see all the towers which have height greater than equal to 1, uh, we have to basically count the number of towers which have height greater than equal to 1. Those form the first number in the array basically. And the second number would be all the towers which have height greater than equal to 2. The third number would be all the towers which have height greater than equal to 3, and so on till n. So we can easily find it out by using two pointers, right? Like because the array is decreasing. So consider like this was the array 4 5 3 2 1. This is decreasing. So what we can do is the last number would be the smallest one, right? So if I want to check for each of the numbers for int I equal to 1 to I less than equal to n, how many numbers are greater than equal to it? So what I can do is I can take one pointer which is equal which starts with n equal j equal to n, right? So I have to check what is the first number which is greater than this number I. So what we can do is while a of j is greater than I or less than equal to yeah, while a of j is less than equal to I. Wait a minute. Uh, if while a of j, yeah, my bad. If a of j is less than I, yeah, we'll do j minus minus. Yeah. We have to put one more condition: j is greater than equal to 1, and because j is the first, 1 is the first index, can't go beyond that. If j is greater than equal to 1 and a of j is less than I, what does it mean? Like if I increase I equal to 2, then what would happen is 1 would be less than it. So basically j pointer is the rightmost pointer. So we get all the numbers starting from 1, index number 1 to index number j, which are greater than equal to the number. So currently j is equal to n, so all the numbers from 1 to n are greater than equal to 1, because a of j is less than a of j is greater than equal to I for this j. Now we want to find the last j so that it is greater than equal to I. So what we do is we do this while a of j is less than I, we just decrement j. Now basically we'll make it make the another array equal to b. So b of I equals to j minus basically it is j, b of I equals to j. This tells us a total numbers which are greater than equal to I. So after that we just check if a is equal to b, then yes, else it is no. This is the simple solution for this question. I can show you my code also. Probably Codeforces issue. Yeah. So yeah, this is the same approach I was following. So I take another array b. So basically I have take zero based indexing. So j is equal to n minus 1, while j is greater than equal to 0, and a of j is less than I plus 1, j minus minus, and b of I equal to j plus 1. If a is equal to j, yes, else it is no. Simple. Now moving on to the fourth question.
और
Ice cream balls.
जैसे मैंने
Yeah.
लिंक्डइन पे ले
So yeah, uh, this question is Tama has learned how to make ice cream cone using exactly two balls. So basically, a cone contains exactly two balls. Now, Tema was interested in a mathematical problem. He is curious that what is the minimum number of balls he needs to have in order to make exactly n different types of ice cream. Basically, the number of balls means that we can have all the balls of different flavors. It's our wish what is the flavor exactly. So using those balls, how many different ice creams can we make? Uh, so n can be till 10 raised to power 18, which is huge. So, in order to understand the question, let's take this. Consider that we have some 7 balls, and these are the following are the flavors of these balls. So, what are the all possible pairs in this? Like you might calculate it manually, but I can calculate with a different method. It would be 22. I guess it is 22. No, 12, I guess. Yeah, 12 it is. So, okay, given a set, what is the formula for this? Like, even if the flavor is something rather than one, it is six. Basically it has no use case. So flavors are basically from 1 to n, right? So if we see there are n different flavors, consider that n different flavors, and other than that, uh, we can take it this as k, and we can take l different flavors. Among these k balls, there are l different flavors. Now, uh, if there are k different l different flavors, so what are the all the possible ways to make the ice cream for if the pair is always different? It is l into l minus 1 by 2. But there are how many of them are same? Basically, how many of them are repeating? How many of the flavors are repeating? It is k minus l. So now, basically, we don't know what are these numbers which are repeating. So if it is always the same number, if consider that k minus l is take l equal to in this case l equal to 5, right? So k minus l is equal to 2. uh, yeah, wait a minute. Sorry for the delay. Huh. So in this example, if we see, there are basically two flavors which are left over are same. And here if we see, there are basically these two are also different numbers, right? These two are also different numbers. So if you see what extra pairs are there, 1 comma 1 and 5 comma 5, basically which the two numbers are same, that those pairs are adding in this. So the formula is always l into l minus 1 plus how many are extra. So in order to maximize this number, uh, if we want to take some same flavors also, we just add, basically we take 1 1 each if we want to take. Like basically if k minus l is 2, we take it as exact 2. Basically these two are also different numbers. We try to keep it this way. And why do we do it? Like I'll explain it to you. Like if consider a number n, if we want l into l minus 1, uh, basically how can n be formed? So always there is a number l into l minus 1 which is less than equal to n, because this number has to come some way or the other. Now, uh, what would be L plus 1 into L by 2? It would be greater than N, right? These are the two conditions, obviously. So basically L into L minus 1 by 2 is the highest number, so that this is true. We actually want to minimize the number of balls. So that's why we are trying to basically maximize the number here. So we can't take basically we have to take L different numbers, right? We always have to take L different numbers. And now how do we make N? Because if you see now what how many more pairs do we need to add to make n? And this number is always less than equal to L, because if you see the difference between L plus 1 into L by 2 minus uh, L into L minus 1 by 2. This comes out to be, if you see L, this is equal to L. So it means that n is less n minus L into L minus 1 by 2 is less than equal to L. It means that if we take every one of these if we even if we
One
repeat
second.
every one of these L numbers, it won't exceed n. So it means that n can be formed. Basically, if you read the question, they have said that it is always possible to make the answer as n. So yeah, here it is always possible to make the answer as n, because we can add at least L more pairs. So when we have found this L, the answer is basically L plus n minus L into L minus 1 by 2. This is the answer to this question. Like, simple as that. So we just need to find this L so that it is less than equal to n. So how can we do it? N is basically 10 raised to power 18. So we can use binary search on answer to find the maximum L so that L into L minus 1 is less than equal to n. So this is how I have done. This is my approach. I have found it by binary search. Basically, I have found the other way around. I have found the numbers which is greater than equal to n. The least L which is greater than equal to n. So I found that L. So I just put some condition. It can be done in a simpler way, where we find the highest L which is less than equal to n, and we simply write L plus the formula I wrote here. So yeah, this is the approach to this problem. Now I'll move on to the fifth problem, Kolya and movie theater. So if you see, there is an array given where A of I means that what is the entertainment that the movie provides, right? And D is some constant which defines how much entertainment decreases over the days. And M is the number which tells us what is the maximum number of movies we can visit. So we need to find the maximum sum of entertainment. So let me, for example, take this one only. 3 to 5 4 6. Uh, 3 5 2 2 3 to 5 4 6. So array equals to 3 to 5 4 6. So the thing is, on the first day, he can either watch this movie or don't. On the second day, he can either watch this movie or don't. This is how he is going to proceed. He can at most watch two movies, and over the days, the number of days he hasn't seen any movie basically increases basically it decreases the entertainment level by d into the number of days he hasn't watched a movie. So if you see, if he watches the movie on the first day and he watches the movie on the third day, basically on the first day, the number of days he hasn't watched a movie was one. Basically, it is the difference between the last watched movie. So if he after watching the first movie, he watches fourth movie, it is d into 3. It would decrease by d into 3. Here it would decrease by d into 2. If he, after watching the first movie, it watches the third movie. So basically, it is always the difference between the last watched movie, right? So let us consider, he only watches movie till a particular index x. He watches a movie till a particular index x, right? So what is the now if we want to know the total decrease that has happened till now over all the movies he has watched, what would it be? Like, what would it be for for an index x, which where x is the last movie he has watched? After that, he doesn't watch any movie. Let us consider x is 4. So if you see here, d is dependent on the last movie he has watched. So let us take basically here the what would be the decrease? Basically, decrease is equal to 4 minus the last movie he has watched, which is let us consider the index is I and D. 4 minus D. Let us just sum up the count rather than D. We won't consider D currently. We'll sum up the count. After that, now we come to the index I and D. Right. We'll come to the index I and D. Consider that I and D is 2. Now, if the number is on 2, if the person has watched the movie on the second day, now if he watches the movie on the first day, what would be the decrease? 2 minus 1. Now he watches the consider that he has watched the movie on the first day, so it is obviously always going to be decrease is going to be 1 minus 0, because it always starts from the 0. So if you see, it is quite obvious that if he watches a movie till the last day he watches the movie is X, the total sum of the decrease is always going to be X into D, because it doesn't matter when he watched the last movie. Actually, it is going to sum up. All the decrements are going to sum up to a constant value, which is the last day he has watched a movie. So we can do one thing. We can iterate over all the last days from 1 to n, right? And we can maintain a multiset where we uh, we keep on inserting all the values and take the maximum m ones. And how do we like take only the maximum m ones? We can just make a multiset and don't let the size exceed m. Like we can use a simple method where we don't let the size exceed m. As soon as it exceeds m, we remove the first element. So that's how we do it. And also we consider the case where a of I is negative. So if it is negative, we don't add it into the multiset. So I'll show you my solution once. I've taken a multiset here, S. Now, answer basically denotes what is the like entertainment value till now, and X denotes what is the answer. Basically, I take maximum among all the answers over all the last dates. Basically, I have to iterate over all the days, right? So I have to take maximum over all the days. So if a of I is greater than 0, I put it into S, and I increase the entertainment value into I basically add the entertainment value into the answer. And if size exceeds m, I decrease the entertainment value of the first element from the answer, and I also remove it from the uh, multiset. Now I also decrease D because day by day there is a decrement of D. It doesn't matter what was the previous day the movie was watched, but the total decrement is going to be D only. So yeah, X equals to max of X comma answer, and that's how we get the answer. If anyone has any doubts, can ask. Now moving on to the next question. Magic will save the world. So yeah, so who is there? Yeah, yeah. So Vika has some magical powers. Where she can increase her every day. She can increase her water magic by F, water magic by W, and fire magic by F, and it keeps on increasing day by day, and by this value only. And there are some n number of monsters where every monster has some particular strength. So monster can only be defeated if some either of F and F or W is used. Like we can use either of F and W, and if that is greater than equal to the strength of monster, she kills the monster. So she wants to find the minimum number of days so that she can kill all the monsters. So how we are going to do that? Basically, it is totally dependent on how which all monsters are killed by her firepower, and which all monsters are killed by her water power. And if you see n is less than equal to 100, and the S of I, which is the strength of the monster, is less than equal to 10 raised to power 4. So what we can do is, if we can make a subset of all the, basically if we can make the subset of all the like strengths which can be which are going to be defeated by fire. So if we can make all such subsets, then we can easily like find out for all such subset what is the minimum answer, right? Like if we get it for all the subsets, then obviously it is going to be the correct answer. And now, but considering all the subset would be like the time complexity would be very high, right? So if you see what matters in the subset, the sum of powers of monsters, right? The sum of strength of monster. If the sum of strength of monster is let's say x, so f should be greater than equal to x. So we want to find the minimum possible multiple of f such that it is greater than equal to x, right? That would do for us. And same goes for w. Basically, w would be s minus x. Basically, consider s as the sum of the strength of all the monsters. So the leftover subset is for w. So we just make the w just greater than equal to the leftover sum. So there are actually 10 raised to power 6 sums are only possible, not more than that. So what we can do is we can make a DP of 10 raised to power 6 size so that we can know what all sums of subsets are possible. So we can iterate over each of the n, each of the monster, and we can just update the DP. So the time complexity would be 100 into 10 raised to power 6 at max. So like if we see there is an array of monsters, something like this kind of thing. Okay, and now if we make a DP array which contains consider that some of the monsters is some of the strength of monster is s. S is equal to sum. So for all possible x belonging to 1 to n, basically it means the subset of n 1 to n. So what we can do is this is the basic idea. So all possible x means that x is the sum. So if I have got a sum x, what would be the minimum possible? What would be the minimum multiple of f, which divides it? So I want that number basically, the number with which I should multiply f. So it can be found by x plus f minus 1 upon f. Basically, it is the seal of x by f, and it can be found by this. And the leftover sum is s minus x basically. S minus x plus w minus 1 upon w. I'll take minimum of both of them. Minimum of both of them would give me the correct answer, and I'll take minimum among all of them. So what I do is I make a DP of size s plus 1, and DP of 0 is initially 1. Then I iterate for each of the monster strength. After that, um I iterate on each of the strengths in DP from backwards. So j equal to s, j is greater than equal to a of I, because basically currently we are going to add a of I, right? So it can't be less than a of I. Yeah, current strength can't be less than a of I, because otherwise it we won't be able to add that the strength of the monster into this number. So dp of j is or equals to dp of j minus a of I. So it gives us all the possible sum of strengths which are possible for all the subsets. So we just iterate for each of the sums, and if we see basically we see if dp of I equal to 1, if dp of I, then we just do this. We take the minimum of this number. Yeah, we take the minimum of this, and we also take a variable answer which is initially 1e6, because 1e6 can be the maximum possible answer. Answer equal to minimum of answer comma. Sorry, I have made one mistake. It is maximum of both of these. It should be maximum of both of these. Because the one which is higher is the total maximum time, the time it would take basically. So yeah, this is the approach for this problem. And this is the solution for this problem, something like this. Yeah, so this is the same way I have done it. And now I move on to the last question. So an array of number is given. There are some specific operations performed on it. First of all, we remove all the duplicates, and after that we see if the length of the array is 1, then we return the answer. Otherwise, basically we add n to the first number, n minus 1 to the second, n minus 2 to the third. First of all, we arrange them in non-decreasing order, basically kind of increasing order. Yeah. So it means that if all the numbers are equal, then only we'll get the output as we'll take the output. Then only we'll take the output. Otherwise, we have to perform some of these operations. So what are these operations actually doing? Let us consider an increasing array only, something like this. So what actually matters after this? What would happen? 1, 4, 7, 10 would remain basically, right? And after that, we'll be adding n to the first number, n minus 1 to the second, n minus 2 to the third, and n minus 4 to the last one. Basically, 1 here, 2 here, 3 here, and 4 here. 1, 4, 7, 10. Now, after adding, what would happen is 1, 5, 4, 5, 7, 9, 11. This would be the new formed array. If you notice what is happening, basically the difference is decreasing by 1 in between every number, right? After that, what is going to happen? It is going to remain the same, and again we'll be adding 4 here, 9, comma 10, comma 11, comma 12, something like this. After that, again 13, comma 13, comma 13, comma 13, and this would make the array equal, right? I guess. Yeah. So if you see what is happening here, when do the numbers converge? Basically, it is dependent on the maximum difference in any adjacent pair. Basically, it is totally dependent on the maximum difference among the adjacent pairs, because the difference of adjacent pairs is decreasing by 1. So the answer and always 1 is added to the highest number. So whatever is the highest difference, we just add it to the highest number. So here the answer would be 10 plus 3, 13, because 3 is the highest difference. If we see for every other possible array, here 2 comma 4 comma 8, if we see 8 plus 4 is equal to 12, so 12 should be the answer. But now this is quite simple, but there are some queries in it, and the queries being we change a of I to x. Basically, we are after every query we are changing some number, so the difference is also changing, right? So first of all, we should check our theory with respect to queries. So if the array was 2 comma 4 comma 8, so what is after the first query, what would be the answer? uh, Sorry, after the first query, what is happening? It is becoming 6 comma 4 comma 8. The What is the answer to this one? It should be 8 plus the maximum difference. So 8 plus 2 is 10. So the answer to the first query is 10, right? Now, what is the second query? Second query is changing 2 to 10. If we change the second number to 10, 6 comma 10 comma 8. So the highest number is 10, and the maximum difference is again 2. So 10 plus 2, 12 should be the answer to this query. It is. Now, what is the third change? We change the third number to 1. 6 comma 10 comma 1. So highest number is 10, but what is the highest difference? It is 5. So 10 plus 5 is 15, which is the answer. Yeah, so this theory works, and this is the logic to the question. But how should we do it after every query? We can't do it in O of n square. So what should be the method? Basically, the thing is we can use multisets. In one multiset, we can maintain all the numbers of the array, and the other one we can maintain all the differences. and we can take maximum number plus maximum difference. But how are we updating after each query? The thing is, if we change a particular if we change a number at a particular index, what is happening? Uh, like consider if we are changing in 2 comma 4, we are changing 4 to some other number. So basically, we are changing the adjacent differences only, right? Adjacent differences to this number. So we can remove the adjacent differences, 4 and 2. We can remove initially what were the differences in the multiset, 2 comma 4, right? Now what we can do, we can remove 2 and we can remove 4. The multiset becomes empty. And we are going to add the new form difference. If we remove 4, what is the difference now? 8 minus 2, which is 6. So the current multiset is 6. Now we have removed 4. Now we have to add insert something, which is 6. Basically, we are replacing 4 by 6. My bad, my bad. Sorry, this is like, let us consider the query is 2 comma 6. This is the query. So first we are removing 4. After removing 4, something like this happens. Basically, we are changing the multiset of all the array. Basically, 2 comma 4 comma 8 was the multiset. Now that multiset is 2 comma 8 only. Like we maintain two multisets, right? So we are changing them after each operation. So first the erasing operation happens. Now we do the inserting operation. After inserting, the first multiset becomes 2 comma 6 comma 8, and the second multiset, if we insert 6 in 2 comma 8, what is going to happen? The new two differences are formed, and one difference is removed, right? So 6 is removed, it becomes empty. Now two differences which are added are 2 comma 6, 4 comma 2 are added, 4 and 2 are added. So these are the new differences which are added. So we can do it like this. The thing is, it takes a bit of implementation. We just have to find the iterator of the current number, and we have to just take into account the adjacent iterators. So the approach is quite complicated. I can just show you my code a bit. I can explain my approach a bit. So initially we add all the differences from the multiset into the multiset R. R is the multiset of differences. S is the multiset of array numbers. Now, there was one case where n equal to 1. In that case, I just print x because it doesn't matter. Basically, there is no need to maintain the multiset S and R. So here I take the lower bound S, it gives me the iterator to A of k. Basically, the number which is currently being removed. I have to remove it. So what I check is, basically I have to take the previous iterator to it. So I check if it isn't the beginning iterator of the multiset. If it isn't, I can take the previous iterator and I can just erase the difference. Then I check uh, the iterator which is going to come next, and basically remove that also. And I then basically insert the new form difference. And why have I have taken this condition? Because it can happen that it is in some corner. If the number is in some corner, we don't need to basically insert any other difference. So it won't be inserted if it is the last element of the or the first element. So this was the erase operation I've erased, and insert now starts the insert one. I insert this in the set, and I make a of k equals to x. And basically, the for the insert operation, it is just the inverse of the first one. Where I was putting insert, I would put erase. Where I was putting erase, I would put insert. Otherwise, it is the same code for insert and erase operation, just interchanging. And in the end, I just print out the last element of each of them. Basically, add the last element of each of them and print it out. So this is the solution for the last question. If you have any doubts, you can ask. Otherwise, I guess I'm done with with today's editorial. So thank you for attending. I guess we are done. So bye bye.